Alright, we ready? Did I hit the button? Okay, so chapter 6 is really, really short for us. Okay, as in we can be done with chapter 6 by Wednesday. I know. Well, we only have to do 3 sections. So, here's my plan. Okay, shh. We only have to do 3 sections of chapter 6, and we only have to do like a couple sections of chapter 7. So my plan is I want to get 2 tests in there, so you have 2 more test grades in before we start doing the AP review. Okay? Shh. So, we do have to cover this other random topic. So I'm going to put that in at the end of chapter 6. We'll probably do that random topic on Friday. Okay, and put it in with this stuff. Thursday I will not be in class. That doesn't mean don't show up. Okay, I'm going to have something for you to do. But I might be here for the first few minutes, but I have to be over at a breakfast at 7:30 or something in the morning, so. I have to be at the Student of the Month breakfast for this month, so. Huh? I didn't get teacher. I nominated a Student of the Month, so. It has to be a senior. So. Maybe, we'll see. Alright. I'm looking for my answer key. I thought you were gonna take BC because your sister took BC. You were at the beginning of the year. You said you had to. Alright. Alright. Okay. Keeping that. Okay, let's do this. So, we're gonna determine whether this particular, okay, you guys are listening, whether the function is a solution to the differential. So we're doing something similar to what we did on Friday. I have to fill this in. So what do I need to find? What does the instruction say? The first derivative, right? So let's calculate the first derivative, and then we're gonna plug in here and see if we can get the x cubed to the times e to the x out of it. So what rule are we gonna? Excuse me. What rule are we gonna need? Product rule. So I'm going to keep the first. Derivative of the second is what? E to the x. Good. Plus keep the second. Sorry. Derivative of the first, keep the second. Keep the first, derivative of the second. Derivative of the second, which is?
Keep the second.
Keep the second. Derivative of the first is? I don't know why I'm screwing it up this morning. That was bad.
It's okay.
I know. Apparently it's too early for me too.
Everyone does it.
Okay. Alright, so now what I'm going to do is I'm going to plug into here, right? I'm going to plug into that thing. So I've got x, and I have to put in y prime, what we just calculated. And then minus 2y. What is y, though? So I'm going to substitute what y is into it. Now I want to try to simplify and see if I can get this thing out of it. So what are we going to do with this x? Distribute it. So you got x cubed e to the x plus 2x squared e to the x minus 2x squared e to the x. No, because this was the parentheses ended here, right? The 2 is just with this back piece. Okay? And these are multiplied, so there really isn't a distribution. Alright, what happens? Yeah, we're going to cancel the back 2. Did we show what we wanted to show? Yeah, that one was better than the one we just did in homework, wasn't it? A lot better, yeah. Okay. Let's look at number 5. We're going to verify that the general solution satisfies the differential equation, and then we find the particular solution that satisfies the initial condition. Okay. So the first thing I have to do is try this in general, which means I'm going to take the derivative. Okay? So I'm going to take the derivative and try to prove this. Okay? And this one's acting a little different than the last few. I'm just going to try to take the derivative the way it looks. Okay? So, what's the derivative of 3x squared? 6x dx, right? Alright, because we're doing this implicitly. Alright, what's the derivative of this one here? 4y dy dx, and then what's the derivative of a constant? 0. It almost looks like it, not quite. We have a number in front, don't we? So what could I factor out? A 2. So that's left behind with 3x plus 2y. Now, instead of dy dx, isn't dy dx the same as y prime? So couldn't I write it as y prime? Yeah, it's the same thing. There are some people who won't do the dy dx, they'll just write y primes. Okay, so you might run into a college professor that instead of doing dy dx will write a y prime. Okay? Alright, what are we gonna do with this 2? No, we just factored it out. Divide it to the other side, right? So you've got 3x plus 2y times y prime equals 0. Did we prove that this worked? Yeah, we got that. Alright. What we're going to do now is we're going to solve for the constant. Okay? So this is typically where the initial condition comes in, is we've got a constant that we need to solve for, and that's where we end up using it. So I'm going to go back into this equation here, and I'm going to use these values. That's the initial condition. Okay? So 3, and what are we going to put in for the x? 1 squared plus 2, 3 squared equals the constant. Right? Because I'm going into this original one. I'm going to try to solve for the constant now. So what's 1 squared? 1 times 3 is 3. What's 3 squared? 9 times 2 is 18. 3 plus 18 is? So 21 is your constant. So now what you do is you go back and you rewrite this and put the constant value in. So 3x squared plus 2y squared equals 21. So that's what you would get as your final answer. No. I have to rewrite it again, but plug what we solved for C in. Okay? You're going to do that on the AP test on a free response at least once. Okay? At least once. Okay. Alright. We good? Example 5? Alright. We're going to switch gears a little bit. We're going to use integration to find the general solution of the equation, so this isn't anything new probably. I'm going to move the dx to the other side. So x cosine x squared dx. We're going to go ahead and add our integral symbols in. We always try u substitution first, right? So what's your u going to be? Let's try x squared. So that means du is equal to what? Do we see the x dx? Yep, but we don't have the 2, so I'm going to move the 2 over. All right, when we integrate dy, what do we get? Y. Okay, we're going to put in for the u. So cosine of u. For the x dx, we put in 1/2 du. So when we integrate cosine, what do we get? Sine. And then instead of writing u, what would we put in for the u? X squared. If you want to write the whole other line, that's fine. They didn't give us an initial condition, so we don't solve for C this time. They said general solution. Okay? All right. We're going to flip into slope fields again. Okay? So, a differential equation and its slope field are given. Determine the slopes, if possible, in the slope field at the given points in the table. Okay? I'm not sure why we would try to read them off the graph when we have the function. Okay, so I'm just going to use the function, and we can kind of use the graph to verify that we're doing the right thing. Okay? So, I have the two numbers. I'm going to plug them in here. So, what is -4 minus 2? -6. So, if I went to -4 about 1, 2, 3, 4, and +2, does it look like about a slope of 6 or -6? At least it's going in the negative direction, right? That's the idea, is you could verify it by looking at the graph. Okay? Alright, what about -2 minus 0? What do we get for that? -2. Alright, what about, let's see, 0 minus 4? -4. 2 minus 4? -2. 4 minus 6? Negative 2 again. And 8 minus 8 is 0. So if I went out, let's see, 1, 2, 3, 4, 5, 6, 7, 8, and I bet that's 8. See how it's flat right there? Yeah. I don't know why they gave you the slope field when we could have just used the dy dx to calculate. All right. Let's look at this one. So what they want us to do here is match the differential to the slope field, which we did a little bit last week, okay? You're probably going to do more of this on Thursday. That's probably the activity I'm going to have for you is matching slope fields to their equations, okay? Probably using, I don't know. Oh, I know what I think I can use Desmos to do it now. So, you could use the t-chart to do it. We can, or I could just start testing a single point. So here's what you want to do. So you want to find where there's a difference in the graph. So look at all the 0, 0s. They're all the same. So is 0, 0 a good choice? No. So let's pick something else. Let's look at this one right here. How about 0, 1? At least I would knock off one of them, right? So I'm going to put in the point 0, 1. Okay? So when I put in 0, 1 for this one, what do we get? 1, right? So this one has to be B or C, doesn't it? So our choices for that one are B or C. All right, when I put in 0, 1 for that one, what do I get? I get 0, right? So 0, that one better be A. Okay, and then when I put in 0, 1 for this one, what do we get? We get 1. So that one again is in our BC. Okay, it's B or C. All right, so now I want to look at graph B and graph C and look where there's another difference. And I want something easy to calculate. Look at this value right here. Everybody see that value right there? See how it's flat on one of them and it's got a slope on the other one? All right, so what is that point? 1, 0. Let's try 1, 0 and see what happens. So when I put 1, 0 into this one, what do I get? 1. Okay, and when I put 1, 0 into this one, what do I get? 0. So which one has to be B and which one has to be C? 1 is B, okay, because it had a little bit of a slope here, right? And then 2, because it was flat, is C. Okay. Sorry, 3 had to be C. All right. I think that's it, right? Oh, no, there's one more. 9. All right. One more. All right, so we have to sketch the slope field for the differential. Again, we did this last week. Use the slope field to sketch the solution that passes through the given point. They didn't give us a point, did they? All right. And then discuss the graph as it approaches infinity. All right. So here's where we're going to use our little t-chart thing again. So we're practicing that. Okay. And we use the t-chart until we can find a pattern, right? All right. And y prime, again, is the same as dy dx. I'm going to start with our favorite point, 0, 0. What do we get for 0, 0 when we put it in? 0, perfect. So I'm going to put I get 0 right there. Okay. All right, I'm going to go for 0, 1. So I'm going to go up. So when I put in 0, 1, what do we end up with? 1. So I know I've got a slope of 1 right here. What if I put in 0, 2? If I keep going up, what do I get for that slope? 2. So I should be getting steeper. Okay. If I went, let's go down. So 0, negative 1. What do I get for that one? Negative 1. So it looks like it's kind of it's doing the same thing but opposite going down, right? All right, let's see what happens if I I'm going to put in the 1 row and see what happens, okay? So if I put in 1, 0, what do I get? A slope of 2. Okay. All right, if I put in 2, 0, what do I get? 4. So it looks like as I go up and as I go down, let's go the opposite direction. Let's put in, I went the wrong way, didn't I? 2, 0 is this one. Okay, should look steeper, which I didn't make it really look that much steeper, did I? Okay. All right, let's see. Let's look at 3, 0. What do we get in there? 6, so it should look even. So it looks like as we're going out, we're getting steeper. Let's go to the other direction. Let's go to the left. Let's see what happens if it goes negative or something. If I put in negative 1, 0, what do we get? -2. So it looks like as we're going this way, we're getting steeper again, right? But just with the negative tilt on it. So let's look and see if we can figure out what's going on as we go up and down, okay? So if I go up, so I go to 1, 1, what happens there? 3. Okay, so it looks like it's getting steeper. All right, and if I go to 1, 2, what do I get? 4. Okay, so I'm getting steeper that way. All right, I'm going to kind of continue my T-chart over here. Hopefully I don't need the whole thing. All right, let's just try to get this column, and then I think we'll probably be able to see a pattern. All right, so this one is out 1, down 1. So what do I get for that value? 2 minus 1, right? You were right the first time, Jordan. All right, so we'll slope of 1. So it looks like it's getting less steep as we go down, right? And then if I go 1, -2, what do I get? 0. So it flattens out. So here, look at what's happening. It's steep, getting less steep, flattens out, and then goes negative, right? All right, so I don't know that we're going to see any others flatten out here, but we know we've got to get more steep as we go up and a little bit less steep as we go down, right? And then we know going this way that we're just going to get more and more steep, right? So I'm going to kind of do a more and more steep thing going this way. Okay. They did not give me a point. I'm going to say we're going to use the point 0, 0. Okay? They were supposed to give us a point. Do you kind of see the picture that it's making? All right, I'm going to use my little highlighter. So there's 0, 0 is my point. They're going to give you one. I didn't for some reason. So I kind of am making some kind of a shape that kind of looks like that. Okay? But what they really want me to do is there's one other piece of the instruction here. It says, discuss what's going on as my x's go to positive and negative infinity. So as my x is going this direction, where's my y going? Infinity. So as x approaches infinity, y approaches infinity. But they also want to know what's going on when x is going to negative infinity. Where's y going when x goes to negative infinity? It's still going to positive infinity. So as x goes to negative infinity, y goes to positive. Remember, this is a tough thing. We did this in math analysis last year. As we go more negative on the x, the y is going up, right? So it's positive. All right, I think that's it for today, right? Okay, so I gave you a homework assignment. It's posted there. If you have homework that you want stamped, you can come see me. We need at least, hopefully you have up through week 5. If you don't have up through week 5, today is your day. You need to get it done, right? It should have been done last